Hello, we are the team of Santiago Orta and Gianluca Arzani, and we are going to explain Lewis structure. So the Lewis structure is a two-dimensional diagram that represents valence electrons in molecules as dots and bonds between those valence electrons as lines. It will be used with molecules, most of them, and well, it is useful to know how how molecules form bonds and how they are connected, plus their formal charges and their the dipole moment. So now I will give some examples of how to do this. First of all, we will use a very simple example, which is water, the molecule water. So water is also written as H2O, which has two molecules of hydrogen and one of oxygen. Now, we will use oxygen in the middle because of the simple rule that it is only one. But in other cases, we have to use the specific, almost every time if we have oxygen, it has to be in the middle, so it can form the bonds. So now we will just write hydrogen, 100 hydrogen, one oxygen, and another hydrogen. And now there are two important rules. First, hydrogen follows the duet rule, which means hydrogen will be happy with two valence electrons. So we always have to look to give hydrogen two valence electrons, and every other element follows the octet rule, which means it will need 8 valence electrons to make it very stable and happy. So now, in this case, what I like to do is first look at how many valence electrons each element has. We can see this with a periodic table, or we can just look it up in the internet. So in this case, we know hydrogen has one valence electron, but we have two molecules of hydrogen, so for hydrogen we will have a total of 2 valence electrons, and we know oxygen has 6 valence electrons, so in total we will have 8. So first, what I do is just form a single bond between all of them. So now we count, each line counts as 2 because it is formed by 2 valence electrons, and if we have a bond like this, hydrogen has 2 valence electrons, but also oxygen has, if we only look at this. In this case, hydrogen, this molecule of hydrogen, this particle of hydrogen has 2 valence electrons. Oxygen has 4 valence electrons, and this other particle has 2 valence electrons. So now we have 4 in total, which means we are missing another 4. So in this case, hydrogen already has 2, so it is already happy, both hydrogens. So now, and oxygen has 4, so the 4 remaining will directly go to oxygen as single dots. This is a very easy molecule. Now we will go in a bit of a harder molecule. So this is SO3, which will be formed in the next way. One molecule of oxygen, particle of sulfur, another of oxygen, and another of oxygen. So now we know again that oxygen has 6 times 3, it will be 18 valence electrons, and sulfur has 6 as well, so in total we have 24 valence electrons. So now, first, as always, we will form the single bonds, and now we know we have 2, 4, 6. We have 6 valence electrons, so now we just have 18 more to go. We also see that sulfur has 6 and every oxygen has 2, so none of them are happy. So if we start by filling out the 18, we can do it like this: 1, 2, 3, 4, 5, 6, oxygen's happy. 7, 8, 9, 10, 11, 12, oxygen is happy once again. 13, 14, 15, 16, 17, 18, and all the oxygens are happy, but sulfur is not. So in this case, we have to form what is called a double bond. So any oxygen will take 2 of the valence electrons, and instead of having separated pairs, we will now have a double bond. So now this oxygen has 1, 2, 3, 4, 5, 6, 7, 8, and sulfur has 1, 2, 3, 4, 5, 6, 7, 8. So they are all happy. Now let's go with another example. Just calcium and oxygen. Now, calcium we know has 2 valence electrons, and oxygen has 6, so it is a total of 8. So now it doesn't matter the order, we can just, well, it does. We have to write it as the molecule is, and yeah, we do the same, but we already know this is a very easy example because we know we will only form unless one of these is hydrogen, then we can just draw the 4 lines because we have 8 and they can all be shared, so they both will be happy. The same happens when we try something like salt, which is sodium and chlorine, which we know sodium has 1 valence electron and chlorine has 7 valence electrons. So the same, we have a total of 8, and we don't need to worry on this. We just share the 8 of them. And now let's do an example where we have hydrogen, because then the thing changes a bit. So we have 2 molecules of hydrogen and 2 molecules of carbon. Now we will write it this way: hydrogen, carbon, carbon, hydrogen. So hydrogen, as we already know, has only 1 valence electron times 2, because we have 2 molecules of particles of hydrogen. It's 2, and carbon has 6 valence electrons times 2. We have 12, and in total we have 14. So now we first form a bond between all of them, and we have 1, 2, 3, 4, 5, 6. So minus 6, we only have 8 remaining. But we know hydrogen is already happy because it already has 2. In this case, carbon has 4, and this other carbon has another 4. So we are missing 4 for each. So we will just write the 8 remaining. Yes, the 8 remaining as 1, 2, 3, 4. I think I messed up a bit. Oh yeah, I know why I messed up. No, I don't. 1, 2. Yeah, both carbons are already happy. Yeah, okay, no, I didn't mess up. So we can see hydrogen has 2 molecules, two valence electrons. Carbon has 8 valence electrons. This carbon also has 8 valence electrons, and this hydrogen has 2. So now, for the formal charge, I will only do one example, because it's the same for all of them. I will do the example of these molecules. So we know that actually I'll make another.